MCs. I'm really privileged to give this keynote talk today. And just to make it clear, I am named after a mathematical function, min. I'm glad my parents didn't call me log, okay? But I thought I'd take a more generalist approach for this keynote, which is, what is a pre-mortem? How many people here know what a pre-mortem is? Okay, a few of us, right? So what is a pre-mortem? It's an exercise that we do to understand what are potential problems that could arise from taking a decision. And we do it before the problems appear as a way to prevent failure, right? So let's say open research dies. It died 2024. What went wrong? It's 2024. We have our hospitals overwhelmed. People are dying. There's a lot of disease going around, and the ward is overcrowded. People are overwhelmed. Why did this happen? In supermarkets, NTUC, Fair Price, other places, okay, cold storage, we find that our citizenry is worried, okay? We've found out after months of figuring out that actually this disease was caused by the spread of viruses, but it may have been acquired through migrant workers coming into Singapore. And then families take their children and they say, you know, it's more important that we have safety for our family. We are going to discharge our workers and they'll go back home and we'll have to take up all of the work on our own, okay? This is, again, a hypothetical situation, not necessarily politically correct, but just one that we want to play out to better understand what might happen. Why could open research help save us from this peril? Okay. So I was a reporter during this 2024 crisis. I went to the ward. I asked people in the ward, what happened? Why did this come about? Okay. Well, actually, the doctors there told me, even though they were very tired, it could have been prevented. But because there was interplay between the politics and the science, the community, things didn't quite gel well. There was no collaboration. This outbreak had happened in several countries, not just in one. And different countries, nationalistic agendas wanted to sequence the genome of the virus. And they wanted to take credit for it rather than collaborating to find a solution faster. Pharmaceutical companies also raced to get to the vaccine, but they did not want to share their findings with each other. They wanted to get the profits and the limelight of having the solution. And because of this and the delays that happened, the epidemic got out of control. Okay? Individual good from state actors, from individual scientists, trumped the collective good to save lives. And that is why we find ourselves in this predicament today. I ask you, has this happened before? How many of us say yes? Yes, it has. In some ways, we could say that pandemic of HIV, AIDS was in part caused by this type of problem. The HIV virus was sequenced in two different institutions, one at, I think, NIH, and another one at the Louis Pasteur Institute in France. They did not share a lot of the data. Okay, it also had to deal with a population that people weren't, at that point in time, very concerned to save. For these reasons, in part, not entirely so, AIDS left as an epidemic for many months, for many years, wasn't completely controlled, even today. So open research died again in 2024. What can we do to save it? Well, we know all of our speakers today have told us what we need to do. We need to be fair, okay? So findable, accessible, interoperable, and reusable. I think pretty much everyone in this room knows what those things mean, but I didn't. So I went back to the provenance to study what it meant. So what is open research anyways? Okay, let's take a look. Open research is a spectrum. It is actually a time scale. We have to find the research. We have to be able to access it. We have to interoperate with it. And we need to reuse it, okay? So it is talking about a life cycle, right? Because you have to find things in order to use them, and you have to build upon them and interoperate with them before you can republish and make better on the work that stands before you. It's the last part of R. And it's no coincidence that it's called FAIR, because together, collectively, these things help us make sure research is fair and ethical, okay, equitable. So let's take a look at each one of these in tandem. And because we're all experts here, or at least not me, but all of you, then let me go through what they mean. Findable, right? To me, this means what is your permanent address, right? Like when we send letters or email, they have to get to a particular spot for the recipient to open, right? So it means being able to figure out where the items are located. And if you look at the FAIR guidelines, this is what they say. They say metadata are assigned globally, right? And persistent with persistent identifiers. So we can know where that data is stored. Importantly, we see that metadata is inextricably linked to the data, right? It's data about data. We need to know what the metadata, what it specifies, and which one it's linked to, which pieces of data that it's linked to, right? And secondly, very importantly, there's an expansive notion of what data is construed as. It's not just biological data or sequence data. It is the algorithms, the tools, the recipes, the workflows that we use that also needs to be codified and understand what's going on. How about accessibility? To me, accessibility means this, as an open access, right? We've heard about open access gold, open access green. Had a nice discussion about this during tea break, okay? And again, the FAIR guidelines are very clear about what this means, okay? All metadata are retrievable. They need to be retrievable by their permanent address, by their identifier. Metadata are also accessible even when the original data might not be available any longer. And to me, as a non-specialist in open access, I interpret that as making sure that all the things that we talked about in the earlier keynotes about IP, about training, all of these things go into the idea of accessibility. Okay, it's baked in as a first-class citizen. And again, metadata is distinct from data, even though it's inextricably interlinked, right? It is a separate entity that we are catering to. Interoperable. Let's make sure we're not talking chicken and duck to each other. And this is a really, really hard problem. Everyone in semantics will tell you that one agency means this, one agency means that, and they're almost the same, but not quite. And where do they differ? That's really, really hard, right? So to be interoperable includes qualified references to other metadata and making sure we have a formal vocabulary for what these things mean, right? They have to follow the same FAIR principle guidelines that we use in constructing our metadata. Again, it means extensibility because we know having one size for metadata doesn't fit everyone. So it's important to have a lowest common denominator like Dublin Core that makes it easy for anyone to participate in the conversation. You don't need to be an expert. With more training, you can have higher fidelity. You might contribute better quality products, but we want to enable everyone to get in on the open access and open research. And it promotes, and very key to my talk, it promotes research and interoperability from an AI perspective. If you actually read the FAIR guidelines, it's prescient in that, okay? It specifically says we believe the future, even in 2016, will be with automation. Maybe not AI specifically, but now AI is here. What about reusability? Okay? Stand on the shoulders of giants, right? Be permissive where possible, like Julia said before, but restrictive only when necessary, right? So to be reusable means all of these privileges that we have here, right? Principles, right? Being able to associate provenance. Where does the data come from, right? Being able to make sure that it is reusable for whichever population needs to use it, whether it's a domain-specific application or a general one that only needs counts and statistics. All of that is predicated on what we mean by reusable. Okay? So it is very much like a lot of us in this room who are professors. It is imbuing the idea of a citation network, right? Because we cite each other, we build on science, but we want it not only for our papers, our scholarly artifacts, but also our data as well, right? Our workflows, right? And it means that we have granular data licensing, just like Judith was saying earlier, right? If we want to say certain parts of our data are interchangeable, or Wilson also said this as well, then we let these be governed either by access rights or time restrictions such that we can inform and make the data as open as we can get. Okay, so I know many of you know this already, so I don't think we want to spend a lot of time on that. So I'm going to spend the rest of my talk talking about why open research matters and the implications of AI on fairness. So what's the consequence when we have unfair research? Okay, I painted you a post pre-mortem earlier, right? That is one possible outcome, but there are many others, right? If we don't have accessibility and findability in our research, we won't know what we're working on. We can allocate too much budget to doing the same things and being in a race with each other. Why compete when we can collaborate wherever possible, right? There's a corollary to this, which is, importantly, a lot of what we do to find information these days is proxied by computer algorithms, by recommender systems. A lot of us and our students are no longer seeking the help of reference librarians for solutions. That could be a problem. We've seen other areas of our lives, such as politics, influenced by filter bubbles that come with the type of technology that my faculty computing produces. Okay? When we have these increased costs, these are also translated into things that producers of that research need to take into account. Our NUS libraries and NTU libraries will tell you that their budget is shrinking while the amount of pay that they have to give to journals is increasing. Okay? This means slower and more expensive scientific progress. And worst of all, it means that not everyone can participate in our research. We have a problem where we have a lot of our population that does not have equitable access to these resources. And that makes it a self-reinforcing loop. We've seen in many presentations, in other keynotes, in other open research conferences, that there is a problem with the self-reinforcement loop. So how do we solve this? One way is to do what people call verification, right? Which is take data and create metadata from it, but follow a standardized process to do this. And there's a citation there. I checked it, it is accurate, okay? Where you can go and figure out, the broad steps of how we do this. Because, despite all of these keynote talks, the risk is to actually make that data and to make it high quality and to train the people to do it. That is really, really hard work, okay? And that becomes a big wicked problem because like all of us have impressed today, like uh, our last keynote speaker also alluded to the problem that there are so many things that need to come together. It's a tapestry of problems, of people that need to be coordinated to be able to figure out a good solution. It is a wicked problem, okay? And fairness does not impact everyone in the same way. It doesn't impact the ecosystem uniformly. There are going to be consumers like AIs that use our metadata that we provision in high quality, but we won't necessarily see the benefits accrued back to the people who had to take the cost, whether it by government mandate or by voluntary efforts. Okay? So it's imperative that we maintain incentives to be able to guarantee that there is good opportunity access for those who need to participate in the conversation, whether you're an end stakeholder or a data provider or somebody who trains. So, does that mean all research should be closed? And Wilson gave us a case where that's not supposed to be the case, right? For example, in MOHT trust, right? We want all of our medical data to be protected. It shouldn't leak out. We don't need to out people. But there are other cases where closed research makes a lot of sense. For example, for a national imperative. For example, the US Manhattan Project. You cannot expect that you would want to share military secrets, okay? Or for competitive advantages, right? So there are many cases of big pharma needing to do things under closed doors to make sure that they have profit to uh, be able to recoup the cost and then more for their drug development. And this is true for publishing models as well. Okay. Finally, there's vertical integrations. If you look at Apple and how it is able to control everything about its design of its laptops, its UI, its app store, it's all to create a experience that is counter to the open culture that we see in the Microsoft Windows ecosystem. Okay, so unfairness, where could it come from? There are so many ways that we can understand that fairness and unfairness might want to creep in. For example, the digital divide, as I alluded to first, right? We have reusability, but for different people, we can further deepen the digital divide in research collaboration, right? And on the other side of the fence, for why open research matters, we can see that being able to open research will facilitate accelerated innovation atop common metadata, right? We can use the fairness principles to instigate different levels of metadata so that we can find the right purpose and reuse as accordingly. So the pre-mortem, okay? We want to say there is the possibility of success, right? That we don't have to fall prey to these problems with unfair research. We want to encourage foundational and, very importantly, long-term funding to ensure that open access is not prey to terms in office, as Jerry alluded to earlier, right? We want to advocate user education, as Judith said at her first talk, right? Julia said at her first talk, to be able to facilitate the discovery of tool use and potential collaborators. Okay, So I'm going to end my talk now with a couple minutes about implications of AI. This is where I spent most of my time on my slides for, and I hope you will engage me with some questions. So I think we can't spell fair without AI, right? It's there, it's a fact, okay? Whether you want to interpret it literally or figuratively is up to you, okay? But I think it is part of the future. So what does this mean? Well, let's harken back. There was a 2021 session of open research generated by Force 11. Who here knows Force 11? A couple of us, okay? This is a consortium of different stakeholders to try to cover the wicked problem of open research, okay? And some of our institutions in Singapore are part of that, okay? And they hold a conference every year, and 2021, as it should come from no surprise to you, was an online conference, right? Okay, so actually all of their keynotes are online, and I spent the better part of yesterday night watching them all and summarizing them using ChatGPT, and then checking the transcripts to make sure that the things were correct, okay? We have to check our sources, right? Okay, so you can see some of the things that they said there, right? Sustainable funding for open discovery infrastructures, improved metadata through good training practices, and an inclusive discovery platform that integrates various forms of research output. Now, as I alluded to before, fairness principles, they are principles, they're not a standard. It just guides you about how you should go implement those those principles. But they are right there in the wording of those statements. They support AI. Just the emphasis on conventionalized metadata, accessibility, provenance, and interoperability, all that help AI and machine-guided algorithms by design. That's a very, very powerful statement, okay? And findability, I think, is the F in FAIR, but it is a related matter. And we've seen how the filter bubble and recommendation systems gets into a lot of trouble. And I put this as a thought for you, okay? When you discover data sets, how do you find them? What algorithms are you using? Is there any bias that you know about those algorithms? Because it will come to bear on whether we think our work is fair in the future. Okay, so I'd like to remove the F in fair and say that AI has more to do with errorification. Okay, so we want peer error for cases of COVID-19 and things like that. So I came up with this without any help from AI. Okay, so to say that, in fact, using AI does help if we use it properly to address the problems of being able to engineer AI appropriately. Okay, and I hope, again, you will dialogue with me on this. Okay, as a developer of technologies and large language models, I can tell you that automated metadata extraction from scholarly articles is something that we are very interested in working towards. Pulling out which studies are randomized controlled trials, which ones are local trials, how many subjects are there, are they from Southeast Asia, what ethnicity are they from, what sex are they or gender they are, okay? All of that is possible, probable, outcomes of AI. Now, provenance is also something tricky. We know that in getting people to cite information, to write software citations, it's really hard, right? Because you can write a nice framework like CCF, Common Citation Framework, but will anyone use it? Unless it's mandated, probably not, right? You can volunteer, you can do it for a small amount of data, but your exhaustion and fatigue will set in. It's difficult to manage it. We want high quality data, we have to mandate it. But there's the possibility and glimmer of hope that something that doesn't tire, that can work day and night shifts 24/7 and crawl through all of your data can do that for you. Okay? And if that's not enough, we see a lot of researchers in our areas also looking at automated quality detection, meaning using another large language model to check those that did the second point, see whether the provenance, whether the licensing, all of that metadata extraction is properly done. Will it actually work? That is for us to determine, and we need everyone involved in that conversation. I think this quote beautifully summarizes it. Okay? Winston Churchill said at the end of World War II, okay, when they were rebuilding the Parliament building, okay, we shape our buildings. Afterwards, they shape us, right? We shape open research, but the research comes back and shapes the next generation of scholars on what they want to do, what type of problems are affordable to do. Those decisions come now when we design that data, when we decide which type of data to make open and at what level of standard. I want to close with a couple caveats because I'm also in charge of ethics in Asia for the natural language processing societies, okay? So all the people who work on large language model safety, okay? Which is to say AI tool development is really, really fast. We all know this, okay? And our adaptability is much slower. There is going to be a growing opportunity gap, okay, where individuals can take advantage of these tools faster than human adaptability. And it will be more so, but slower for institutions and likewise for governments like Singapore and also all of humanity. That gap exists. It is widening and it's a concern, okay, whenever we want to employ AI for any of those use cases that I pointed to on the last slide. Finally, a note of weapons of math, not mass, math destruction. So some of you may have read this book. It's from Kathy O'Neill. And she says, importantly, when thinking about the ethics of AI and machine learning and algorithmic qualities, we need to worry about the case of things that are created, decisions that are massive, opaque, and there's no feedback loop, okay? What am I talking about? I'm talking about Amazon using algorithms to hire more white men, or in the UK, when they were going to use a computer algorithm to decide which people to admit to a university by correlating it with past historical records. All of these perpetuate bias if we are not careful about the design of the algorithm, okay? In all of these cases, whether it be a bank loan, admissions to a prestigious university, they are all important decisions. They are massive. They're opaque. Nobody knows how it's done, and there's no feedback loop. You can't tell the university, hey, my daughter should have been admitted. Now, this comes to a very, very important point, which is the class break. What does a class break mean? It means that with one simple algorithm, I can unlock all the doors that use Bluetooth, okay? It used to be that you needed a key, and NUS is old enough that we still use keys to open doors, but you could only break in one office at a time, okay? With the class break, that means we can break open every lock at the same time, expose all of the data to possible misuse. This is what I want us to also worry about as an emphasis today as well, reiterating and reinforcing Jerry's talk. Okay, so what are the weapons of math destruction in our FAIR research? And that's all I have for you today. So if you want to see the slides, you can take a copy of that QR code as well. Thank you so much for the opportunity to talk to you.
Thank you, Prof. Tan. I think we have time for one question. There are a lot of questions for you, and I think we're going to channel that to the panel discussion for others to comment on. But for you, have lessons really been learned post-COVID in terms of prioritizing sharing for the collective good over shareholder profit? And if so, what are they?
So the AIDS epidemic, I think, is one crisis that people and healthcare really thought about when they were engineering how to deal with SARS in 2004 and also with COVID-19 in 2019 and 20. And I think it is a good point to say that we feel that we have succeeded. And, there's lots of improvements to be made for sure. But I think because we have seen these problems before, and because we have the foresight of doing pre-mortems, we can possibly handle more of these problems. But it is a wider gap because the technology is speeding up, right? If we want to safeguard things, we actually have to slow down to speed up. Okay, we need to put more time to thinking about these wicked problems before they get out of hand.